Welcome back to Code Meets World. Today we're going to be looking at the last easy problem in the bit manipulation category, which is called missing number. So in this problem, we're given an array of nums containing n distinct numbers in the range 0 to n. Return the only number in the range that is missing from the array. Okay, so between 0 and n means we're just given every value between 0 and n except for 1. I think that's what it's saying. So for instance here, n is 3 because that's the length of the array. And we're given every value between 0 and 3 except for 2. Because we should have 0, 1, 2, and 3. But we're missing 2. So we just return 2. Same down here. We should have 0, 1, and 2, but we're missing 2. Here, if n is 9, we should have 0 all the way through 9, and we have everything here except for 8. So that's what we're missing. Okay, yeah, this is an interesting one to do with bit manipulation. So let's talk about how we might do that. First, I'll quickly mention how I would probably do this if I wasn't using bits, which is that I would probably take all the values in nums and put that into set 1. So that would just be 3, 0, and 1. And then I would make a second set. And here I would put all the values between 0 and n. So I would put 0, 1, 2, and 3. Then we could do something really easy, which is just say set 2 minus set 1, because that would take every value in set 2 and subtract out any of the values that appear in set 1. So basically, the 3 would get taken out, so would the 0, so would the 1, and we'd be left with 2, which is the solution. Now this would work, but as you saw, we're in the bit manipulation category. So we need to figure out a way to do this just by shifting bits around, which is super fascinating that can be done. But I think the trick is to remember what the XOR, so let me just move the set solution out of the way. We need to remember the XOR bitwise operation. I'll put a link at the top of the screen to a video that I did recently where I explained the XOR operation and how it might be useful. So go ahead and watch that if you haven't, because you'll remember two interesting properties that I explained in that video. One is, if we take any number and we XOR that with itself, and the caret means XOR, we get 0. So whether that's 1 XOR 1 or 3 XOR 3, this always equals 0. And this is good for canceling out values, and that'll be useful in just a second. Another important fact about XOR is that any number XORed with 0 equals that number. So 1 with 0 or 3 with 0 equals 1 and 3. So how can we leverage all of this to help us solve this problem? Well, the idea that I have is this. Say, for instance, we take, I won't write out all of these numbers, but say that n was 5 or something instead. So nums might be, for instance, say 0, 5, 4, 3, 1. So the value that we're missing here is 2. We're missing the 2 value. But then if I make another array of just all the values between 0 and 5, we would have 0, 1, 2, 3, 4, and 5. So can you see the trick with how we can use XOR to find the one value that's missing? We can cancel everything out. If we XOR everything together in these two arrays, so just XOR all of the values together, one by one, we know that when the values are the same, we get 0. So these will cancel out. The 1s will cancel out, so will the 3s, so will the 4s, and the 5s will cancel out too. We'll be left with 2, the missing number. Because XOR is commutative, so it doesn't matter what order we XOR these values together in. As long as we're just XORing every number together, we're going to be left with just the number that's missing, which is super, super cool. So I think that's all that we need to do here. Let's talk about how we might write this in the actual code. So I think this is going to be maybe a 1 or 2 liner because we really don't have to do much. We definitely need a for loop where we say I think we need the index and the number. So I think we can say for index num in, we'll use enumerate, so we have access to the index, and that's over nums. And then I guess we need, like I've done in all the bit operation videos, we need something, I usually call it solution, that we're going to manipulate with the bit numbers and then return at the end. So now it's just a matter of what we do to XOR everything together. So one thing we can do is say solution is solution XOR, which is the caret, num. So what this is going to do is half of what we need, I think, because what it's going to say is take 0 and then XOR that with every input in nums. So that's great, but then we also need to do it with all of the values between 0 and n, which we can get for free. This is nice with the index, right? Because the index is going to loop from 0 up to the length of nums. Now remember in Python, because it's 0 indexed, index is going to start at 0 and go up to, if n is 9, it'll go from 0 to 8. But I think we want between 1 and 9 because we already have 0 for free here. So we don't want to XOR with 0 again. We want to start with 1. And then we don't want to end at 8. We want to go all the way up to 9. So I think we can say XOR again with whatever index is plus 1. And I'll put those in parentheses so it's clear. But I think now we have everything we need because we're going to start with 0. We'll XOR onto that the values, for instance, in this example, the values 1 through 9. So we'll have 0 all the way up to the length n. And then we'll also XOR all of the nums in the input array. So then everything should just cancel out and we should just be left with the solution that we want. Let's see. So yeah, the test case is passed. And fantastic, that one passed. And you'll notice that 18 minutes ago, I submitted this solution, and that's because the first time I recorded this, I did not have my microphone active. So I went to start editing the video and it was just completely silent. So I had to record it again. But it looks like we got a way faster runtime. So yeah, the solution is the same, but this one happened to run a lot faster. So 93rd percentile. This is as fast as you can do it. And of all the bitwise programs that we've done in this category, this one's definitely my favorite. I think that this is such a clever solution and really interesting how a problem that you would never think needs bitwise operations can be solved with them and really quickly and in pretty much one line of code. So I hope you enjoyed this one and I will see you again in the next video.